But yeah, we're Movement Labs, kind of co-founder, rolling M2, a move-based zero-knowledge rollup for safe blockchains. The agenda is glossary, kind of going into words, but you probably gonna get that. Context, problem, solution, architecture, and kind of where we're headed. So M1 is kind of our decentralized sequencer network. I'll get more into that. M2 is kind of the main kind of product, which is zero knowledge rollup. A VM is a virtual machine that executes smart contracts on blockchains. The main one, obviously, is the Ethereum virtual machine. And then we see the Solana virtual machine. Now we have MoveVM and a few other groups launching their own tech stacks and programming languages and customizations. And the EVM is hot garbage. Movement SDK, our software kit to execute smart contracts. The MoveVM, which is a VM part of Atlas and SWE. For those who aren't familiar, Move started off as a DM project within Facebook. Facebook essentially wanted to build a stable coin to power the biggest consumer app in the world. They looked at the EVM back then and wasn't scalable. Solana VM also was good, but not great, and wanted to bring a next generation framework to start the DM project. SEC was like, nah, you guys can't do that, and it's brought up to Aptos and SWE, which were the main L1s that kind of took on Move narrative Move language. Fractal is our EVM interpreter, so essentially we enable Solidity script to launch, transpile Move bytecode, and launch on the virtual machine, so providing backwards compatibility for existing EVM products, and then a zero knowledge proof, essentially a zero knowledge proof. DA layer, essentially ability plus call data to alt DA. So yeah, I think it's over $7.6 billion lost hacked so far. Last year we saw $4.2 billion lost. So the thesis behind Move is really smart contract security. The biggest issue besides speed and kind of localized fee markets in the EVM is also security. We want to build secure systems that Bank of America and the biggest kind of applications can actually use and rely on. So Move was built by Facebook to have security in mind. Here's kind of a breakdown of attacks we're seeing today. A lot of these attacks are smart contract attacks. We're seeing re-entry bugs, like verifier bugs, signature exploits, Oracle attacks, kind of like a breadth of all different code-based attacks. And then long story short here is 90-95% of every EVM app you use on Ethereum mainnet and layer 2s is at risk of being attacked. This is because there's no formal verification built into runtime. So when developers, whether you're a new developer, experienced developer, they're pushing code that isn't always bulletproof. We saw the Curve attack, we saw the Kyber attack. These are two blue chip protocols that this year or last year got hacked, and that shouldn't have been hacked. These are some of like the biggest protocols, yet it was a small bug that basically rendered the entire system useless, and you had a Kyber dictator after that. So the Move language was built with formal verification in mind. You have the Move prover built into the system. So every time you execute a smart contract, it checks the resource, type, and memory safety, which is a Move prover really spearheaded by Wolfgang at Aptos Labs and previously DM. So essentially, when you execute a smart contract, especially a Move smart contract, it checks, hey, is there integer overflow? Is there a re-SRT attack? Is there a type mishap? And how can we provide solvency for that? And like throw up a compiler flag if needed. In the traditional EVM, this doesn't exist. So if you have integer overflow, it gets pushed to mainnet, which can be exploited. And it's the root cause of a lot of attacks we're seeing, especially in re-SRT. Here's a little bit of developer count. So Move developers are at the market cap's at 5.5 billion time this is written, around 230 devs full time, while Solidity and Ethereum alone is 2,300. So the thesis of Movement is trying to bring this new cutting edge Move language, which was launched post FTX around a year ago, and bring it into Ethereum and EVM and kind of combining the best of both worlds while living as a layer 2 on Ethereum. So can we enable safer smart contract execution with Ethereum? And can we bring Move to Ethereum? The answer is yes. We have a Move-based rollup living on Ethereum. Rollups, I don't kind of skip to this because I think you guys kind of get what rollups are. You have two main styles. You have optimistic rollups, which have fraud proofs and challenge periods. And you have ZK rollups, which is validity proofs, which are fast but very computationally expensive. A lot of the work that we're doing is exploring like zero-knowledge Move circuits. Currently looking at a ZK fraud-proof solution as kind of the first main step, but kind of the step after that is building out a ZK Move, which gets me particularly excited, but it's also very difficult from a computational point of view because you have high proving costs and high low proving speeds that are generally low. So something that from a 3-year lens, we're looking to kind of bring that to market. So M2 is a Move-based zero-knowledge rollup on Ethereum. Here's a little bit of the architecture. You have the Movement SDK, which is kind of where you can reach consensus. So You have a move zero knowledge rollup living on Ethereum for settlement, and then a proof marketplace that for now will be outsourced, but potentially looking to build an in-house one. And yeah, essentially this kind of walks through that. I'll probably answer questions after this about this, but essentially it's you have move execution layer, Ethereum for settlement, alt DA for data availability, which is like Celestia and EigenDA, and then you have a shared sequencer, which enables sequencing of transactions. Here's a little bit of the EVM runtime. So we actually enable full EVM compatibility at the bytecode level. We have full pre-compiled support for any EVM smart contract, safe facility script getting launched on the VM, as well as any move contract. We also support both Aptos and Sui style move. Sui move, for those who aren't familiar, is more in line with like Solana style, where Aptos move is from the DM project and keeps in line with that. Here's a little bit of the transpiler, or the interpreter we call it, where you have the facility script, you parse that to the abstract syntax tree, boil that down into intermediate language, which is YOL in this case. You map that to the move opcodes. There's like 124 facility opcodes. You map that to 54 move opcodes and launch in the VM. It translates both accounts and tokens. So we actually have a universal token standard. So you have the Aptos coin standard as well as ERC20 that both can interoperate atomically. M1 is a decentralized sequencer. Centralized sequencers today are awful. If you look at Arbitrum and Base, when inscriptions happened, both of them went down to 100 TPS. So if you ever actually have users on chain, it's not going to be centralized. If you look at the playbook for Arbitrum Optimism, they're all going to eventually decentralize sequencer, but they're making a shit ton of money, so they have no reason to do it today. The reason why we're starting off is because we all DA, you have next-gen VMs, so we have a decentralized sequencer off the bat, which lives on a Snowman consensus, which has instant finality. So imagine the first fully decentralized next-gen rollup coming to Ethereum. Instant finality and have the ability to have token value accrual. So the valuers actually stake the token to participate in sequencing, which actually has a baked-in economic incentive for layer twos instead of just being a meme coin, which is like governance tokens. So M1s are Snowman consensus, kind of notable benefits there are you have instant finality or near instant finality. You have very low hardware requirements, so you can run the node on your laptop, and you actually eventually can be permissionless. So the vision in 2 years can be a fully permissionless sequencer network, which is pretty cool. Proof of stake, it's pretty straightforward. Sequencer network, you have full nodes. You can connect that to a DA layer, which is Celestia, Eigen, Avail, some of these players. And then you have provers that can come into the market, whether it's like Mill Foundation, Rusiro, Bonsai, whatever. Back to architecture. A little bit on ZK Marketplace. This is kind of where we're spending the next bit of research on ZK Move. We've archetyped two main solutions. We have a Rusiro kind of approach that we're looking into, and then we're working closely with the Polygon team to explore a Polygon 2 solution. The main kind of thoughts and kind of trade-offs here is how can we generate proofs that are not too computationally expensive, but also can keep up with the throughput and performance of MoveVM. Something like this has never been really done before. So we're actually scaling the research team out and spending a lot of resources on kind of benchmarking. The current approach is a Rusiro fraud proofs, which is pretty straightforward. But then from there, we're looking to see if the Plonky 2 or a Rusiro implementation makes sense. So the current goal and kind of where we're at is the Rusiro fraud proofs, like I touched on. You'll have Moon SDK, you have sequencing with Snowman consensus, Ethereum for settlement, Celestia for DA, and the Rusiro fraud proofs, we're working closely with them, is kind of the current progress and where we're launching DevNet and testnet with. The next goal is like really on the custom ZK Move VM, whether it's running on circuits with Plonky 2 or the risk circuits that we're kind of exploring. Move Stack, we actually just announced Gaiman yesterday, which is the first BNB chain rollup. So we actually brought the Move VM to BNB chain. There's a whole team building out a gaming chain. I believe it's a game in China that has like 1 million users or something. And then launching the first gaming rollup on Binance, which is very exciting for us. It's also CoinMarketCap incubated, so interesting there. We're having a fully decentralized sequencer. And I think on the last bit is use cases. I think there's a lot of infrastructure in today's market. So the question is, okay, with all these L2s and L1s, what's the clear value profit differentiator? I think security is a paramount thesis in that if you have all these parallelized VMs in today's market, the question is going to be like, okay, is the difference 10K versus 12K TPS? Probably not. It's who has the great throughput and can also protect user funds at the same time. So what we're trying to optimize for is the ability for any retail user, family offices, liquid funds to deploy ETH on chain, natively stake that, restake that, have insurance protocols that make sense. So we're spending a lot of time with IG insurance and trying to create strategies that imagine you can deploy ETH on chain, have insurance models that make sense with insurance rates that make sense, which then incentivizes retail capital to come in because now A, they can deploy ETH and their assets without getting hacked, and B, they have insurance models that actually make sense for the investment. So you actually have this cycle of smart contract security, incentivizing capital, which then incentivizes insurance rates, which then incentivizes more capital. So we've seen a lot of success for family offices who are looking to deploy ETH on chain today. And yeah, super excited to launch incentivized testnet, and thank you all for coming.